This lesson, we're going to look at graphing quadratics when they're in standard form. And so we want to be able to look at a few of the key characteristics. Before we do that, let's review also again what standard form is. So standard form is whenever we have a function in this format here, f of x equals ax squared plus bx plus c. And basically that just means there's a quadratic term or a squared term. Okay, so that's the coefficient of that is a. We have a linear term right here because it's x to the first with a coefficient of b, and then we have a constant term. So again, the main thing is we have that quadratic term, obviously, and then a linear term and a constant term. All right, to find in those key characteristics that we've been looking at, one is the x-intercepts. So we have a couple options. One, we can change the problem. We can change that standard form into factored, or some books will call that root form. So we can factor and set each factor equal to 0 and solve. Another option is we can convert it to vertex form by completing the square. But the first one doesn't always work. We can't factor every problem. Converting to vertex format by completing the square, there's a lot of steps to that. But really the way that works all the time that we can use is using the quadratic formula. So again, if we just set the y value there, that y equals 0, if we set that equal to 0, we should be able to use the quadratic formula to find the x-intercepts if there are any. And just a review of the quadratic formula, that's x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Next, axis of symmetry to go over. The axis of symmetry is, you can find that by doing x equals negative b over 2a. That should look somewhat familiar. It's basically that part of the quadratic formula. So without the plus or minus part, just the negative b over 2a, that is the axis of symmetry. So just find your b value and your a value. Now remember that negative out in front, you can put it on top or on the bottom. So it's negative b over 2a, which really means negative 1 times b over 2a. So you can use any of those formats. Now the vertex, it doesn't matter what format we're on, the vertex is always on the axis of symmetry. So all we have to do is plug in this value, whatever we get for the x-intercept, that's our x value on the vertex. And to get a y value, you just plug in that value. So that's what all the symbols mean for the vertex. Again, these two will always be the same. It doesn't matter what format that we're dealing with. So that vertex is always on the axis of symmetry, and then just plug in. So plug in the x value to get a y value. And that's true for every function. All right, and the y-intercept, it's the same thing for all of them. You substitute 0 for x, so it doesn't matter what it is. So you're always going to do f of 0 or whatever the function's defined as. Now what will happen every single time on those is when we do f of 0, so that's a times 0 squared plus b times 0 plus c, what will happen every single time is 0 squared times a is 0. And then b times 0 is 0. So actually it's just this number right here is always going to be your y-intercept when we're dealing with quadratic functions in standard form. And the same thing is true as before with concavity. That has to do with that a value. That is no different. So if a is positive, it's concaved up. And if it's concaved up, the vertex is a minimum. If a is less than 0, so in other words, if saying this a is negative, it's concave down and the vertex is a maximum. All right, so let's go ahead and practice a few of those. So number 4, find the axis of symmetry. So again, we're just going to use that equation, x equals negative b. So I'm going to put negative 1, just negative, and I'll put a parentheses there. All right, so the b value is right here. It's actually negative 7. Okay, and then we're going to divide that by 2 times a, and the a value is negative 9. And then all we have to do is simplify. So negative times a negative is a positive on top, and a positive times a negative is a negative. And of course we can simplify that, dividing by 2, and we get 7 over negative 18. All right, let's practice finding the vertex. Okay, so finding the vertex, first you have to find the axis of symmetry. So that's exactly what we just did on the last one. It's x equals negative, and then whatever the b value there is. So the b value is positive 6 divided by 2 times the a value. And the a value on this one is 1/3. Okay, and then we have to simplify that. Now this one's a little bit more complicated to simplify. You gotta remember your rules for fractions. So 2 sets of 1/3 is 2/3. So remember, just put the 2 over 1 and we multiply the numerators, multiply the denominators. And then hopefully you remember when we're dividing by a fraction, we'll go ahead and change the problem. That's the same thing as multiplying by its reciprocal. Okay, so the division changes to multiplication, and then we take the reciprocal of the denominator. And again, we just have our rules for multiplying fractions. We can multiply and then go ahead and simplify the answer, or we could simplify first. So we could do negative 18 over 2, or we can simplify first. So 2 goes into both of those, and then we get negative 9 over 1, so just negative 9. All right, now that is the axis of symmetry. We are asked to find the vertex. So the vertex, we know part of the answer is going to be negative 9 something. We got to find the y value. Now to get the y value for any function, it doesn't matter what type of function we're dealing with, we just plug in an x value. So we'll go ahead and copy that function. So f of negative 9, it's 1/3 times negative 9 squared plus 6 times negative 9 minus 2. Okay, so all I did is plug in that negative 9. All right, and then we should be able to do this by hand, but also maybe with a calculator is fine, but I'll do it by hand. So we just do the order of operations. So negative 9 squared is positive 81. I'll go ahead and multiply those. That's negative 54 minus 2. Okay, so I did the exponents. Now we have to simplify that first term. So 1/3 of 81 is 27 minus 54 minus 2, and we could do the rest of that on that calculator if we would like, but that's negative 29. Okay, so again, to find the vertex, we first have to know the axis of symmetry. All right, number 6, find the x-intercepts. So we have some options. It doesn't say how to do it. We could try factoring on this problem. There's a few different things, but I'm going to go ahead and just say, all right, our output is 0. Okay, so that will happen whenever we're looking for the x-intercepts. The y value is 0. Then we just have to identify a, b, and c. Again, I'm doing that because there's an x squared and x to the first. And I guess we could try factoring that, but otherwise the quadratic formula will work. So x equals negative 1 times b. So the b value is negative 8 plus or minus the square root of b squared. So b again is negative 8 minus 4 times a. A is 16 times c, which is 1. Change that to color to match up. All divided by 2 times the a value, and again that a value is 16. All right, from there all we have to do is simplify. So this first one, negative times negative 8 is 8, plus or minus. Negative 8 squared is positive 64. And then 4 times 16 times 1 is 64. Divided by 32. All right, and then we simplify inside the square root some more. 64 minus 64 is 0, all over 32. Okay, and then we take the square root of 0. Square root of 0 is 0. So you could write 8 plus or minus 0 over 32 and separate them, but there's no need to separate those. Adding 0 and subtracting 0 doesn't change the value of that problem, so we'll just say it's 8 over 32. And then we can go ahead and simplify that, and that is 1/4. So there's only one x-intercept. So it just touches that x-axis. So it's 1/4, 0. So when we're dealing with quadratics, there could be one intercept, two intercepts, or no intercepts. All right, and then this next one, we're going to go ahead and find everything, number 7. So again, what is the y-intercept? You are going to plug in 0. Now again, when you plug in 0 on here, you don't have to show your work on this when we're dealing with standard form, because when we plug in 0, those other terms, that will be 0 and that will be 0. Okay, so we know that one of the points, when we plug in 0, we get 6. And then we can go ahead and plot that. All right, axis of symmetry. That is where we're going to do x equals negative b. So the b value there is negative 8 divided by 2a. And a is 4. Positive 8 over 8, which is 1. Okay, so the axis of symmetry is x equals 1. So we can draw that in. If that it's not necessary, but it may be helpful to graph that. So that's x equals 1. So the graph will be the same on both sides of that. To get the vertex is always on the axis of symmetry. So I'm going to go ahead and copy that top equation. So it's 4 times something squared minus 8 times something plus 6, and that something is 1. Okay, and if I were to simplify that, so I have 1 squared, so that's 4 minus 8 plus 6, and that is 2. So there is our vertex. Our turnaround point is at 1, 2. Now, to be honest, that should be enough for us to graph, just dealing with the axis of symmetry. So on this side, we went over 1 to get there, so we can go over 1 right here. So that alone should be sufficient. Also, the things we learned about that a value right here, okay, so it's concaved up, it's going up, but also when we look at our graph from the vertex, we can go over 1 and up a. And so the a value is 4 there, so we can do that on both sides. So really that's enough to graph this. Now on other problems we may need to find more things, like if the y-intercept is something that doesn't fit on the graph, we may have to find some more facts about this curve, but that's enough for this one. But we'll go ahead and just review this, finding the, because there may be problems where you have to find the x-intercepts. Again, we're going to set it equal to 0, and we'll just use the quadratic formula on this one. So it's negative times b plus or minus b squared. So negative 8 squared is 64 minus 4 times the a value of 4 times the c value of 6 divided by 2 times a. And then we'll go ahead and simplify that. So we'll do 4 times 6, which is 96, divided by 8. And then if we simplify inside the square root, the thing's called the radicand, we get negative 32 over 8. And right there, we can just stop when we're dealing with x-intercepts. Because if you were to try that on the calculator, the square root of negative 32, you will get an error message. So on this right here, once you see a negative root, you're going to stop and say there is no x-intercept if we're dealing with functions. So this is for functions. And we can see that from the graph. That makes sense. It doesn't cross the x-axis. Now, if we're dealing with equations, so a little bit different context, we're not going to say there's no x-intercept. We're just going to say no real solution. No real solution if we're dealing for equations. Okay, and we'll go over what that means another time, because there is something called an imaginary solution. Okay, so again, one more quick comment about the points there. The vertex we found, the y-intercept we found, we can graph using the a value also. Remember, we did this before where we said, all right, we have x and 4x squared. So we just took that quadratic term, and we could plug in some numbers and make a chart. So that's 0, 1 squared times 4 is 4, 2 squared times 4 is 16, 3 squared is 9 times 4 is 36. So we could use that pattern. And that actually, this table right here is really helpful if that a value is a fraction, because there's some graphing programs online where you can't go up and down a fraction. So you're going to look for the whole numbers on those tables. There's some con exercises that do that where maybe this a value is 1 1/3. And so if it's 1/3, you're not going to be able to go up 1/3. So you have to look at another point from that table to graph. All right, so a bit of a review. What does the quadratic formula find? When we're dealing with equations, it solves them. So equations solves quadratic equations, equations in standard form. When we're dealing with functions, it finds the x-intercepts. Okay, so again, the x-intercepts, there could be 2 x-intercepts, 1 x-intercept, or no x-intercepts. All right, and then lastly, a little application of quadratics in standard form. Okay, so a couple of things. So this happens when we have free-falling objects, or objects that we throw up in the air and they fall down, or even toss across a field. So the height of an object is modeled by this equation: h of t equals -16t squared, plus people will call that v naught, v sub 0 times t plus h naught. That's your initial value, where h of t is the height of the object measured in feet. V naught is the initial velocity measured in feet per second, and h naught is the initial height of the object, and t is measured in seconds after it is propelled straight up from the ground. Okay, or probably propelled is not the best word, just thrown, I guess, would be a better word. Okay. All right, so let's use that with this next problem. A ball is thrown straight up in the air with an initial velocity of 6 feet per second from a platform that is 15 feet above the ground. So right there, this right here is your initial velocity. So that's that v naught, and then the initial height is 15 feet above the ground. So write the equation. All you have to do is substitute those things. So h of t equals -16t squared plus the initial velocity, which is 6t, and plus the initial height on that one. So your initial height is essentially your y-intercept. Okay, so that's the next question. What is the initial height? That means we plug in 0. And so on this equation, when we plug in 0, remember those first two terms. You don't have to do this on your work for your homework, but remember this is that term is 0, this term is 0. So the initial height is 15. So within algebra, we call that the y-intercept. What is the maximum height of the ball from ground level? Okay, so the maximum height was going to be at that vertex. So we got to think, all right, how are we going to find the vertex? Well, the vertex is on the axis of symmetry. So we do -b over 2 times a. So the a value is -16. And then the b value is +6. And then we just go ahead and simplify that. So -6 over -32, that's going to be a positive number, so 3 over 16. Okay. All right, and then from there, we're going to go ahead and say, all right, how do we get the height? We plug that into our equation, 3/16. We can use a decimal because that's a terminating decimal. But we'll just go ahead and plug that in. So it looks a little sloppy, but we could just use our calculators on that. And we can type that into Desmos and for our calculator, and it'll give us this decimal right there. By the way, in Desmos, if you type that in, there's a little button to the left that has it looks like a little fraction with spaces for numbers. If you click that, it will convert that problem into a fraction. So let me show you how to do that. All right, so if we go into Desmos right here, all right, so I went ahead and typed in that whole expression. I got that 15.5625, and then you just come over here and press that little, whoops, I went too many times. There we go. So if you have to express your answer as a fraction, it'll just convert it for you. You don't have to do it by hand. That is an option. So again, if you're doing some online programs that say it has to be a fraction problem, that's what you're going to do. Okay, and all right, and then last one, when will the ball hit the ground? Round to the nearest hundredth. It will hit the ground when the height is 0. So that's your y value right there. So let's go ahead and say, all right, 0 equals negative 16t squared plus 6t plus 15. All right, so how are we going to solve that? There are two variables. Okay, there's a t squared and a t to the first. So we either need to factor this problem, or we need to change it to completing the square, or use the quadratic formula. I'm not sure if we can factor that one just by looking at it, so I'm going to go ahead and start using the quadratic formula. So it solves for the variable. So the variable on this one's t, so I'm going to go ahead and use t instead of x. Okay, all right, so our b value is 6. And then plus or minus the square root of that b value. So you can go ahead and write b squared, so 6 squared, or you can just write 36 minus 4 times a, which is negative 16, and then times 15. All divided by 2 times the value of a. And so the value of a is negative 16. And then we'll go ahead and simplify that. Okay, so we get negative 6 plus or minus. I guess we could just type that all into the calculator and get 996 over negative 32. All right, and it did say to round to the nearest hundredth, so I don't need to even try to simplify that square root. Don't need to, because it is asking for a decimal approximation. So we're just going to say, all right, we're going to go ahead and split that problem into two different expressions. All right, so the first one, x equals negative 6 plus 996 over negative 32. And just go into Desmos or some graphing calculator that you have and type that in there. And we're going to do that. So it's about negative, oops, oh, my pen stopped working. Negative 0.799, and then also we need to type in negative 6 minus the square root of 996 over negative 32. And if we type that into the calculators, that's about 1.174. Okay, so there's two x-intercepts, but in real life, we can't have, I shouldn't say x, those should both be t. Those t values represent time on those ones. So we're not going to say that it since it's represent time, we can't have negative time. So we're going to go say, all right, that one's not our answer. After being thrown up into the air, it's going to land in 1.174 seconds. All right, let me go over the next one. Won't solve it, just set that up. Starting from ground level, an object launched into the air has an initial velocity of 87 feet per second. At what times will the object be at a height of 31 feet? So again, on this one, first we need to write the equation. So h of t, because of the constant of acceleration of gravity, it's negative 16t squared. The initial velocity, it's going up, so it's positive 87t. And then the initial height, again, it's ground level on there, so it's going to be just 0. Now on this problem, it says, when will the height be 31? So h of t represents the height. So we'll just put that there. And then we're asked to solve this problem, okay, to find the values of t. To solve this problem here, okay, since we have a t squared and t to the first, we want everything on one side. So we're going to go ahead and subtract that 31. And so when we subtract 31 from both sides, we get 0 equals negative 16t squared plus 87t minus 31. And from there, we can we're going to go ahead and use the quadratic formula. We should be able to do that, so I'm not going to take the time to do that, but that's the idea on how to do that problem. So again, the kind of the key for this lesson, we're looking on how to graph quadratics in standard form. We need to work on memorizing this table. Some of the things should make sense. We've done them before, so there's not quite as much to memorize as you might anticipate.